Hello everyone, welcome back to my channel. So in this video we are going to learn about one of the AM receiver, which is tuned radio frequency. Okay, so which is TRF receiver. Okay, tuned radio frequency receiver we are going to learn. If you are first time to my channel, please consider subscribing. So AM receivers is of two types. Okay, so AM receivers is of two types. One is TRF receiver, that is tuned radio frequency receiver, and second is super heterodyne receiver. Super heterodyne receiver, and super heterodyne receiver is the most widely used receiver. Okay, so there is one. I'll explain you when I explain this concept. I'll explain you. Okay, so I'll explain you TRF receiver in this video, and I'll also explain you what are the disadvantages in that TRF receiver. Okay, so AM receiver has three characteristics. Any receiver, one is sensitivity, we have discussed in the previous video, sensitivity. Second is selectivity, and third is fidelity. So all the three characteristics must be perfect for any good receiver. Okay, so sensitivity is the ability of the receiver to amplify weak signals also. Selectivity is ability to pick up the required frequencies and reject all the unwanted frequencies, and fidelity is reproducing all the frequencies at the output of the receiver without any distortion at any frequency. Okay, so these are the three characteristics of any receiver circuit. Right, so now we'll see the block diagram of this TRF receiver. So AM modulator here. So we are using a carrier AC cos of 2 pi FCT, and M of T is being used, and suppose we are transmitting it through an antenna. So transmitting the signal through an antenna, and receiving antenna receives that signal. Okay, so this is Fs and this is also Fs, which is incoming signal frequency. So Fs represents incoming signal frequency, which is a high frequency signal. So it is a radio frequency range signal. Okay, so this is Fs. Right, so as I have told you, the transmitted signal, as channel is free space, it has traveled long distances. So during this long distance transmission, there will be decrease in the signal strength. Yes or no? So there will be decrease in signal strength or decreases. So the first stage of any receiver circuit must be an amplifier. So here we'll take it as RF amplifier, because the signal is in RF range. So Fs only, still it is an RF signal, so RF amplifier is taken. So this consists of one amplifier circuit plus tuned circuit. Okay, so the first stage consists of amplifier circuit and tuned circuit. So why tuned circuit is used? To have the selectivity, to have better selectivity, because once the unwanted signal frequency enters the receiver, and once the unwanted frequency enters the receiver, it is not possible to eliminate that frequency, eliminate that signal of unwanted frequency. Okay, so therefore at the first stage only you have to reject all the unwanted signal frequencies. So for that we need a tuned circuit. So RF amplifier stage consists of amplifier and a tuned circuit, which is tuned to the incoming signal frequency Fs. Right, so only wanted frequency, that is tuned frequency to Fs. So only incoming signal frequency is accepted by this tuned circuit, and all the other frequencies are rejected by the tuned circuit due to the property selectivity. Okay, so even the incoming signal frequency is of very low amplitude, it will be amplified by the amplifier, so that it will have better sensitivity also. so that receiver will have better sensitivity also. So if the amplifier gain is more, then it will have better sensitivity. Okay, so sensitivity and selectivity both are performed in this section only, right? Next, RF amplifier. So once the signal frequency is strengthened and we have the RF signal here, now the strengthened, the restored amplitude will be there in the incoming signal frequency. Now it is given to demodulator circuit. Okay, so demodulator circuit it is given. So what does demodulator perform? So demodulator performs inverse operation of modulator, that is, it converts this high frequency signal into low frequency signal. That is, modulated signal is converted. Modulated signal is a high frequency signal which is converted into audio frequency range, that is low frequency range signal. Okay, so which means a message signal frequency. Okay, so that will be the output. So here the output will be AF signal. RF signal is converted into AF signal by demodulator. Okay, and then since it is an AF signal which is newly formed signal, so it is now first have to be amplified. So AF amplifier, it is passed through an AF amplifier and then passed through power amplifier. Okay, to increase the power level of the signal, to increase the amplitude of the signal and power level of the signal, so that it can be given to any load. Okay, suppose if you are giving it to loudspeaker, so this will be the load here. Okay, so this is the process which is going on in a receiver circuit. Okay, so if all the frequencies are produced at this output, then the quality of this output will be high, so that we can say it as fidelity is going to be high. Okay, so fidelity is going to be high, right? So this is the process of any tuned radio frequency receiver, TRF receiver. Okay, so first stage is, I'll repeat, so incoming signal frequency comes to you, and sensitivity, due to sensitivity and selectivity, so due to the presence of tuned circuit, selectivity is increased, and due to the gain of this amplifier, sensitivity is also improved, and then the signal, the last amplitude due to the transmission from transmitter to the receiver is restored here. So restored amplitude is given to demodulator, restored signal is given to demodulator, where demodulator converts high frequency signal into low frequency signal, that is RF signal is converted into AF signal, and AF signal is again, because it is a newly formed signal, so it is passed through AF amplifier and power amplifier to restore amplitude and power of the given signal of AF signal, and it is given to any load. Okay, so this is the operation. So what is the disadvantage in TRF receiver? The disadvantage in the TRF receiver here is, I have told you the bandwidth allotted to each AM station. Bandwidth allotted to each AM station is 10 kilohertz. Right, so bandwidth allotted to each AM station is 10 kilo. This is standard value which we have to follow. Okay, so these are the standard values which is given by Indian governments. Okay, Indian telecommunication government, so we have to follow this, right? 10 kilohertz. So bandwidth is again depending on, bandwidth is equal to FR by Q. Okay, so bandwidth is equal to FR by Q, which is depending on tuned circuit. Okay, because selectivity and sensitivity, as I told you, it depends on tuned circuit only. So tuned circuit will have tank circuit, right? So tank circuit consists of L and C components, that is inductor and capacitive components. So from the resonance concept, we know that FR is equal to 1 by 2 pi root LC and Q is equal to 1 by R root L by C. Okay, so from resonance concept all this occurs. So all this formula will be getting. So bandwidth is equal to FR by Q. So it is difficult, very difficult to keep the bandwidth constant, so that it will have better selectivity. So selectivity problem arises in TRF receiver. Okay, so for selectivity quality factor must be high. So selectivity depends on quality factor, and quality factor in turn depends on LNC components, and here FR is also depending on LNC components. So to keep the bandwidth constant, but bandwidth must be constant, yes or no, 10 kilohertz. So to keep the constant bandwidth 10 kilohertz, it is impossible to keep FR or Q at constant, because if you want to change either FR or Q, if you want to change FR or Q to make this constant, we have to tune LNC components only. So L and C components must be tuned. So if you are tuning LNC components, both varies. FR varies, that is resonant frequency varies, and also Q varies, because both are depending on those two components, L and C only. Okay, so it is impossible to keep this 10 kilohertz constant, which must be kept constant. Okay, so due to this, if you select bandwidth greater than 10 kilohertz, then adjacent channel interference occurs. Okay, so it will interfere with adjacent signals, right? So when bandwidth is less than 10 kilohertz, then information loss occurs. Okay, so information loss occurs. So bandwidth must be maintained constant to 10 kilohertz is not possible in the case of TRF receiver. Okay, so this is the main disadvantage of TRF receiver. Why we cannot make it to 10 kilohertz? Because you cannot make FR or Q constant. Okay, so in super heterodyne receiver, this second type of receiver, what we are going to make is, we are going to make this FR constant, that is frequency constant, so that you can change only quality factor and we can make the bandwidth equal to 10 kilohertz. Okay, so that we'll see in the next video. Okay.